Welcome back again, solving pulley problems, but this time there is force of friction. I will take about 20 to 25 minutes and I will explain you 4 different problems. One like this, where the force of friction is there, 5 kg, 3 kg. And in the second problem, I will be deriving a general expression. Under what condition this M2 does not move? The value of the masses are not given. And in the third one, to the same problem, force of friction being present here, I will be applying a force F, a pushing force, making some angle theta with the horizontal. You can take theta with the vertical also. And in the last one, the same problem, but there is a pulling force to this side F, making angle theta with the horizontal. So these 4 problems will be discussed. So let us first begin with the one. Let us first begin with the first one. It's important for your JEE Main and your NEET examination, and of course sometimes in your school board examination. The statement of the problem is like this: find the minimum value of the coefficient of friction mu between this mass and the surface such that the block mass 5 kg remains at rest, means this does not move. This mass 5 kg, it is attached to the string. The string is massless, is moving over a pulley. There is no friction in the pulley, and this end of the same string is attached with a 3 kg mass. Now this is from NCERT page number 102. Now, to solve this kind of problem, what is to be understood, that you should know that is force of friction. If I represent it as F, it is mu times the normal reaction, and the direction of normal reaction should be known to you, how it is normal to the surface and how the force of friction is opposite to the direction of motion. And what else you should know, the weight, I write it as WT, weight is mass times the G, means this is a force. Now let us go straight away to the problem. This 3 kg mass, the earth is below it, so its weight will be vertically downward, M times G. So let me show it here. So this is your M times G, that is equal to 3G. Due to this force, this mass 3 kg is pulled down. So the tension in the string, as you know, will be away from the mass, which I have explained in previous videos why it should be away from the mass. Now it is the same string going over the pulley. So here in the string, the same tension for this mass will be to this side, let it be T. Now since the mass is kept on a horizontal surface, its action force will be vertically downward. Let me show it here, and this is your action force. And that will be how much? That will be equal to its weight, 5 times G. So the surface will apply the same reaction force. That will be also normal to the surface. Let me show it in a red pen. So from this point, the normal reaction will be to this side. I represent it as N. Why this is normal? Because this line makes 90 degree with this surface, so this is normal. So, due to the tension T, as this mass 5 kg is pulled towards the right, the force of friction between this mass 5 kg and the surface will be opposite to the direction of motion, trying to, this is your force of friction. Let me show it in a bigger line. Alright, this is your force of friction. I represent it as small f. So that will be mu times your normal reaction. So let us now write the equations. since it is given the 5 kg is at rest, it is neither moving towards right nor towards left. So mass 3 kg will also be at rest because it is attached with the string to the mass 5 kg. So mass 3 kg is neither going down nor going up. Means this is an equilibrium, translational equilibrium. So your T will be equal to 3 times G. That is your equation 1. Now here, if you look at this 5 kg, this is acted upon by two forces, the tension towards the right and the force of friction towards the left. And since this is not moving, therefore neither moving towards right nor moving towards left, of course it cannot move towards left, so T is equal to the force of friction, the same T. So T is equal to force of friction. As you know, force of friction is equal to mu times the normal reaction. In this case, the normal reaction is 5 times G. N is equal to 5 times G. So your T is equal to 5 mu G, the same T. That is your equation 2. This is your equation 1, the same T. So your 5 mu G, therefore 5 times mu G is equal to 3G. G is multiplied on both sides, so G cancels. So mu is equal to 3 over 5. So if you divide 3 with 5, so put a decimal point here, so this becomes 30. So 5 6 are 30, remainder is 0. So mu is equal to 0.6. So that is your answer. Now in the next problem, as I said you before, don't try to remember this as a don't try to mug up. The answer is 0.6. They might change the values here and here, so you'll be in difficulty. So just remember the principles, how you have to balance the forces. Next, let us derive a general expression. The same problem, but let us derive a general expression. Find the minimum value of coefficient of friction between mass M2 and the surface such that the block mass M2 remains at rest. This remains at rest, therefore M1 also remains at rest because it is attached to the string. Both M1 and M2 are connected. If this does not move, the M1 also does not move. Let us derive a general expression. I am taking the one on the right hand side is M1. They might give you this as M2 and this as M1, so you have to be careful. So you need to understand. So the weight of this is vertically downward. Mass is M1, so this will be equal to M1 times G. And the string, the tension is away from it. Since this is neither going up neither going down, so the net force on it is 0. Means your T is equal to M1 times G. Make it as equation 1. And here there is a friction between M2 and the surface. And as you know, if this is trying to go to the right hand side, because of the same tension T, which will be developed in this string for this mass away from it, and since this is not moving towards right, so that is opposed by the force of friction. So the force of friction, let me show it this time in black ink to this side. Let it be represented as small f. This M2 is applying an action force, that is its own weight, acting vertically downward on the surface, M2 times G, the action force. Now, the action force. So the surface will apply the same reaction force exactly in the opposite direction. Let me show it here. So this is your normal reaction. Why this is normal? This line is normal to this surface. So as you know, force of friction is equal to mu times normal reaction, and the normal reaction is M2 times G. So your force of friction is equal to mu times m2 times g. Now, since this is not moving, so T must be equal to F. If T will be more than the force of friction, it will move towards right. So your T is equal to the force of friction, that is equal to mu m2g, the same T. This T and this T, they are the same. Equation 2, because it is the same string. So the general expression would be same T. So mu m2g is equal to m1 times g. Fine. So we are required to find mu. So g cancels. So your mu is equal to m1 over m2. So this is the minimum value of mu. So don't remember this as the if you want to remember, then remember this mass over this mass. They might change this as m2 and this as m1. So you have to be careful. If this is m2, this is m1, then it will be m2 over m1. So this is the minimum value of mu for which the mass m2, which is kept on a rough horizontal surface having coefficient of friction mu, does not move. Now let me go to the next problem where I will be the same problem, but the question is modified. In addition to the force of friction here, which is present due to this coefficient of friction, I have applied an additional force F, this one, F, making angle theta with the horizontal. So now let us see what this F is doing. If you are making some angle with the horizontal, I wish you are familiar with components of a force. You are familiar with components, rectangular components of a force in a plane. Means if there is a force F represented by this line, taking this as the diagonal of a parallelogram, if you construct a parallelogram like this, and this angle is theta, this side represents F, then this much will be your F of cos theta, and this will be F of sin theta. This is the length of this side is same thing as this side, so this will be F of sin theta. So this is what you have understood probably in your school classes. Now since this is F, how do you get it? You take, in this right angle triangle, you take cosine of this angle, will be base over hypotenuse, cross multiply, you will get this as F cos theta. In this right angle triangle, if you take sin theta, it will be perpendicular over hypotenuse, then cross multiply, you will get this side. The length of this side will represent F sin theta. This side is same thing as this side, lengthwise. So this will be F of sin theta. Now this is your F, a pushing force. So this will be your F of cos theta, which I just explained you here. And this will be of your F of sin theta, and its weight is vertically, and its weight is acting vertically downward, right? And how much will be that? Its mass times g. By applying this force F in a slanting manner, making some angle theta with the horizontal, they might give you this angle as theta, so you have to change this to F sin theta and to this as F cos theta. You have to be careful. So a component of this force, that is F sin theta, is also pushing this mass vertically downward. So the net force that the mass m2 is pushing downward is m2g and this one F of sin theta. So this force and this force, they are in the same direction. So the net action force on this rough surface is equal to m2g plus F of sin theta, net action force. So your normal reaction will be, equal to, so your normal reaction N will be equal to M2G plus F of sin theta. And since there is friction, so the force of friction trying to oppose the motion of the mass M2 towards right will be to this side, Let me represent it as small f. So your force of friction will be, your mu times normal reaction, So N is multiplied with mu, so there are two terms here, so I have to keep this thing in brackets. M2G plus F of sin theta is your force of friction. Now you have to be careful now. The weight of this M1 is vertically downward, is equal to M1 times G, the tension away from it is T. The same tension for the mass M2 will be away from it. Now it's interesting. So this mass M2 is pulled towards the right due to the tension T, and the force that you are applying F, making angle theta with horizontal, a component of that, F cos theta, is also in the same direction as T. So on the mass M2, the force towards the right is equal to T plus F of cos theta, and this force T plus F of cos theta is being opposed by the force of friction. So, and since this is not moving, therefore M1 is also not moving down. So the same T, if you look at this situation, your T is equal to M1 times G, the same T. So here the net force towards the right is T plus F of cos theta, and if that is equal to the force of friction, then M2 will be at rest. So that is to be understood. So T plus F of cos theta is equal to force of friction. So T plus F of cos theta is equal to the force of friction. So T plus F of cos theta is equal to your force of friction, that is equal to mu times your normal reaction, and the normal reaction I just explained how it is equal to M2G plus F sin theta. M2G plus F sin theta. Now T, so this is the expression, and for T, from here T is equal to M1 times G. So put here T is equal to M1 times G plus F of cos theta is equal to mu times M2G plus F of sin theta. Suppose you are required to find mu, they might ask you what is the value of F, they might ask you what is the value of mu. So this is the expression. So if they have asked what is the value of mu for which M2 does not move towards right, then from this expression keep mu on one side, so this becomes M1G plus F of cos theta. This was multiplied here, so this comes to the left hand side, it will be divided. Okay, now my suggestion is don't remember this as a formula, you will be in trouble. They might change the question, they may give theta with the vertical, so don't remember this as a formula. They might ask you what is the value of F, so that mass mass m2 does not move. So from the same expression here, now look, there is F here, there is F here. So you have to bring them to one side. So m1g plus F of cos theta will be equal to, if I multiply mu m2g plus mu F sin theta, mu F sin theta, there is a F term here, there is a F term here. So, which will be convenient depending on whether you bring it to the left hand side or this to the right hand side. On that it will depend the nature of the final expression. If I take this to the right hand side and bring this to the left hand side, then you have mu times F sin theta minus F of cos theta. This comes to the left hand side, m1 times g minus mu m2 times g. So if you take F common, you are left with mu of sin theta minus cos theta. If you take g common, so m1 minus mu times m2 times g. So your F becomes, this was multiplied here, so it will go to the other right hand side will be divided. So m1 minus mu times m2 over mu sin theta minus of cos theta whole into g. They might ask you the force, they might ask you what is the value of mu for which m2 does not move towards right. So again I suggest, don't remember this as a final expression, don't mug it up. They might change the angle in the question, they might change, they might say this is m2, this is m1, so you have to be careful. So this was the case of this was a situation. In addition to the force of friction here, there is an additional force applied from outside, F, making angle theta with the horizontal. Then finally let me go to the last one. The same problem here. Now in addition to the force of friction here, I have applied a force here, F here, right? Now so making angle theta with the horizontal, so this is your F of cos theta and this is your F of sin theta. And here the tension already explained for this mass away from it, the same string, the tension away from this mass, the weight of this m1 is vertically downward. Weight is a force, is nothing but its mass times acceleration due to gravity. And since the mass m2 is not moving towards right, so m1 is also not falling down, so your T balances m1 times g. So T is equal to m1 times g. Make it equation 1. Now what is interesting here, you have to be careful here. If the force is not applied, then the mass m2 is pushing the surface with an action force equal to its m2 times g. But since there is a force you are applying here to the mass m2 making angle theta with the horizontal, a component of this force F, that is F sin theta, is acting vertically upward, and the mass m2 is still on the surface. This is to be understood. The mass m2 is still on the surface. So if this was not there, m2 was pushing the surface with a force m2g. Now because of this force, this will be reduced by how much? m2g minus F of sin theta. So your action force is equal to now m2g minus F of sin theta. Why m2g minus F of sin theta? Why not F sin theta minus m2g? Because it is resting on the surface. So this is more than this. So your normal reaction will be same thing as that. So now the force of friction trying to oppose the motion of M2 is towards left. Your force of friction F, that will be equal to mu times the normal reaction, this normal reaction. And in addition to that, the component of this force to this side is F cos theta. So this mass M2 is acted upon by two horizontal forces towards right, that is T, tension in the string, and F cos theta. So these two are in the same direction. So the net force towards the right is equal to T plus F of cos theta. So if M2 is not moving towards right as it is given in the cosine, so this force must be balanced by the opposing force, force of friction. So your T plus F of cos theta is the force of friction, that is equal to mu times the normal reaction M2G minus F of sin theta. And since this is not moving towards right, the M1 is also not moving down. So T is equal to M1G. So T is equal to M1G. So T is equal to M1G. So for T, put M1 times G plus F of cos theta is equal to mu times M2G minus F of sin theta. If you are asked to find out mu, then bring this term to the left hand side. So your mu becomes M1G plus F of cos theta over M2G minus F of sin theta. So for this value of mu between M2 and the surface, M2 does not move towards right, right? Now, they might ask you what is the force? Then from this expression, the F term is here, the F term is here, you have to bring them to one side. So, you have to bring them to one side. Let me write it here. M1G plus F of cos theta is equal to mu M2G minus, mu will be multiplied here, mu times F of sin theta. Now it will be wise to bring this term towards the left hand side because both will be positive. So if you take F, bring this to the left hand side, if you bring this term to the left hand side, this is already positive, this will be positive. So if you take F common, you will be left with cos theta plus mu times sin theta, and this M1G will come to the right hand side. So you will have, this term is already there, mu M2G minus M1G. So now to find F, take this to the right hand side. So your F becomes mu M2G minus M1G minus of M1G over cos theta plus mu sin theta over cos theta plus mu sin theta. Then you can write it in a decent way. It is wise to write expressions in a decent way. If you take G common, so this becomes mu M2 minus M1 over cos theta plus mu sin theta times G. Why I have writing in this way? This is a force, so the right hand side has to be a force. This is acceleration, so this part must be mass. Look, mu is a number into mass is mass minus mass is kilogram, so numerator is kilogram. cos theta is a number, mu is a number, sin theta is a number, so the denominator is a number, mass over a number is mass. So F is equal to some mass times the acceleration. So that is all about. Don't remember the final expressions, mug it up. They might change the theta from horizontal to vertical. They might take this as M2, this as M1. So you have to learn the principles only. Then it becomes simpler to solve, right? So I hope. So we discussed 4 numericals. Beginning with the first one. Okay, all the best. Happy New Year 2022. Thank you.